Hello, how's it going? We're going to talk about units. So, as chemical engineers, units are really important. We use do equations and programming. You always have to worry about units. Have we corrected and used them consistently? There are units packages available like pint and unum, and we'll go over those. I recommend you don't use those, and we'll talk about why. And that instead you just use all of your units are in SI units. And so SI units include the meter, second, kilogram, and Kelvin and mole. Those are like the base units, the fundamental units, and derivative units like the Newton, force, or joule, energy, and Pascal, pressure, and so forth. You can get all of these from combinations of meter, second, kilogram, of course. So Newton, like force, kilogram meter per second squared, and so on. And then there's the prefixes, multiples of these derived units or a base unit. So here's an example calculation where we convert miles per hour to meters per second. So similar to what I said, you use conversion factors to make sure you have everything, all your variables are listed in SI units, and you make sure you give comments on what units the variable might be in. Here I've left those, and then you can do kinetic energy, for instance, 1/2 mv squared, and that's in joules because that's the SI unit. If you have that base units, then you'll get the SI derived unit. So of course, you all have had high school chemistry and other classes that highlight dimensional analysis, so converting between, similar to what I did up here, 20 miles an hour to meters per second. You have this conversion factor, and then this 20 miles per hour cancels with this miles per hour, and you're left with these units here. And you can go even further in depth. I might look this up on the internet, which is fraught with danger sometimes when people report the wrong number. So maybe you want to do a base unit. Google is pretty reliable. So if you find the unit conversion on Google, you can move with that. But sometimes you might want to take it further than. And here's those both of those. And pressure, like the ideal gas equation here, we got PV equals nRT, so 1 mole, then the ideal gas constant, or the gas constant, it's not necessarily ideal, but gas constant, the temperature in Kelvin, and my volume. So those are all in SI units, so because of that, then I get pressure in pascals. CGS units I don't use them as much as the SI units, but you could use those, and that's very common. And our beloved English units, foot, second, pound mass, pound force. Pound force is not a unit, base unit, but is a derived unit. Rankine and mole. And you can use these, and you should be familiar with these as we live in the United States, and engineering is done a lot of it with English units. And this GC factor is critical to make sure you don't make mistakes. So 1 pound mass is 1 pound force. So you're saying, how is that possible? Well, 1 pound mass is, so for example, 1 pound times the gravitational constant of 32 feet per second squared, that would give you 32 pound mass feet per second squared. And in order to get it to pound force, use GC, so you have to divide by GC. And sometimes that can be hidden in some equations, so you just have to be careful with using English units. And here's example calculation to kinetic energy in foot-pounds. And here's some examples of using pint. Pint is one package. So you set it up this way. You import it after you pip install it, and with your command line prompt, pip install pint. And then you set the ureg. You could call it anything right here, this variable, but you're setting quantities. So the velocity here maybe 20 miles per hour, and this has to be part of its library, and kilograms and so forth. And then you can do the equations there. And this works, so it tracks the units and prints them out for you. Here I'm converting kinetic energy to joules, and because I've mixed English and SI units in this equation, but it'll still do it correctly. And notice what type the variable is. So this variable right here, this is a class of pint quantity. So that's why I don't really like using pint. Is sometimes you might want to raise that number, but it's actually an object now, to use it in different ways, and this will cause problems in some cases. The other package is unum, and here's how you might use that one after you pip install unum. And so this one's kind of dangerous, as you can see. If you rename m to something or other variable that it doesn't know what it is, so there can be problems. So here he's got speed, distance times time, so it's used this variable that's internal to the program for unum. You haven't necessarily described what m is anywhere, but it just knows that that's meters. So you can think, if you don't have good tracking of your variable names, this could be an issue. But you can use it. And there's my recommendation I gave earlier. And then this is really important as far as units check on equations. So we went through the ideal gas law up above. You can have one here. Here's the van der Waals equation of state. You want to make sure that whatever units you're using for volume and B, that those units are consistent, that they're going to give you the right unit of pressure. And so instead of putting numbers in here to start with, you might put in the actual units that your numbers are input as, and make sure those units cancel out as you would expect. And then finally here, round off error. Give an example, but Python tracks 16 decimal places, and so it's a good idea to keep that and not to truncate them. You kind of have to do it like here. If I do this cut number here, I'm actually truncating pi to the first digit. So usually this isn't a problem per se, unless you are entering numbers from your calculator sometimes and putting it in Python. Sometimes truncate this because it's a pain to type in all 16 digits. And so that's the benefit of using Python, is you retain all of that information and limit your round off error using Python, and you can maintain this level of data integrity throughout your program. And this here is an example of a program I wrote, just a short one, for loop for seeing what kind of errors are introduced if you truncate to one decimal place. And I've done it here where you multiply the same number, in this case pi, that's been truncated to a digit, one digit, after the decimal, 3.1 for instance, and the number of times multiplied together, how much error you're introducing. So this is trying to convey that if you truncate your numbers prematurely before you report the final answer, you can get some 5%-ish error depending on how many operations you're doing. And this was just multiplication. Round off error can be greater or less depending on the operation. Best wishes to you. God lives and loves us.